Hello, let's do the New York Times Medium Sudoku for May 4th, 2024. There's a link in the description if you'd like to try the puzzle yourself in the same Sudoku Pad web-based software that I do. And I'm going to get started right now. So let's go over some terminology first. This is a cell. There's 81 of them in the grid. We have a 9 by 9 grid of cells. We also have a row, a column, a box. The boxes are these bold outlined boxes. There's 9 of those, just like there's 9 rows and columns. Can't repeat a digit in a box, just like a row or column. And then we also have a band, which is a row of 3 boxes, and a stack, which is a column of 3 boxes. Okay, terminology out of the way. How are we going to solve the puzzle? Well, I use a systematic method that's designed to introduce you to the basic concepts of what we're going to be looking for when we solve Sudokus. It's not the only way to solve Sudokus, but I find this to be the most enjoyable way, sustainable, and also helps prevent mistakes. The more you introduce human error in the possibility, like if you're going to go through every cell and try to mark what it can be, that's 81 chances to make an error. You might notice patterns that aren't there, things like that. It can be very overwhelming. So the idea behind this is to focus on the most important things first and notate things that we want to remember only. Not just notating things randomly for the sake of getting some notes on the grid. All right, so the first thing we're going to do is we're going to focus on bands. By focusing on a single band at a time, we aren't so overwhelmed by the entirety of the puzzle all at once. By focusing on localized areas, we can get some localized deductions that can really help us out and get us through the early parts of the puzzle. For the mediums, sometimes by the time we finish all of this, we've actually finished the puzzle, sometimes not. And so depending on this puzzle, we'll either get that finished through this first pass, or I will go over what to do if you didn't finish from the first pass. Every single time I solve the medium, I am going through it in this step-by-step way and explaining everything as if you haven't seen my videos before. So feel free to watch any of my other medium solves as well if you want reinforcement and different situations for these techniques. Okay, so the first thing we're going to do is we're going to look at the bands. We're going to go one band at a time, and we're looking for when a digit appears exactly twice in the band, where we know where it is. So for example, this 6, we know that it appears here and here, but there should be a third 6 because there's 3 rows and every row has a 6 in it, and there's 3 boxes and every box has a 6 in it. Now, don't get confused. That's not 6 6s. That's still just 3 6s because we are restricted by the rows and the boxes. We aren't forced. I don't know if that makes sense, but you can see that this 6 is both in this row and this box. This 6 is both in this row and this box. So the final 6 is going to be in the row that doesn't have a 6 and the box that doesn't have a 6. So it's going to be in one of these 3 cells. Another way, kind of more straightforward way to think about that, although that is very logically sound, another straightforward way to think about that is that this 6, because we can't repeat a 6 in the row, says that these 3 cells can't be 6. And this 6, because we can't repeat in the row, says these 3 cells can't be 6. So if we're looking at this box and saying this box needs a 6, we can't repeat it in these 2 rows. So these are the only 3 cells remaining that can be 6. And so that's why we're looking for when we have 2 out of the 3, because that means there are at most 3 cells remaining that could be that digit to find that third one. Now, in this case, we know this 3 can't also be a 6. So we're actually down to 2 places in this entire band that can be 6. And the 6 is going to end up either here or here. We don't know which one, and we're not going to guess. Guessing is how you make mistakes. And I'd have a 50% chance of being wrong because I have no idea which one is 6. If I don't know, then I notate. So what we want to do is we want to find a way to notate that to remember that within this box, 6 ended up in only 2 of these cells. And so what I'm going to do is I'm going to use the corner mark mode in Sudoku Pad and put 6s in there. This is corner mark, this is center mark. You can see the difference. They either end up in the corner or the center, so they're very well named. And so when we use corner marks, that is telling us that within the box, that digit is limited to just the cells that we corner marked in the box. Now, I recommend only corner marking if it's in 3 or fewer cells in the box. If it's in 2 cells, you can mark it anywhere. If it's in 3 cells, limit yourself to when they're all in a row. That's my recommendation, because we're going to be looking for things like pointing. We're going to be looking for things like hidden singles. And if you mark it too much, then the box gets overwhelming and it's harder to scan it. And you might miss-scan things. Again, we're trying to reduce human error here. All right, so that was the 6. Now, in general, the strategy I would use to find duplicates so you don't miss any, start with the box with the fewest givens. So this box has just a single 3. And look for that digit in the other 2 boxes. Neither of these boxes have a 3. So now what I've done, I've already done 2 out of the 3 comparisons I need to do in order to compare each box against each other box. So now I just have to compare these 2 boxes against each other, this box against this box. And I already did the 6, but there's also the 8. I look for the 8 in this box, and it also has a repeated 8. So these cells aren't 8. And now what we do is we do want to dip down and we want to look. This is the only time we look non-locally and when we do our band scanning. And I see that there's an 8 down here as well. I'm just looking for an 8. 1 or 2 8's even better. You're not going to find 3. And this 8 says 8's not going to go here. So actually we can corner mark 8 into one of these 2 cells. It's down to just these 2. All right, so that's it for duplicate digits. But before we move on to the next band, there are 2 things I want you to look out for. First, I want you to look out for a filled box row. A box row is where a row and a box intersect, right? And so like this is a box row, this is a box row, this is not, right? That's 2 boxes. We want it to be in 1 box and 1 row. Anyway, so it's a set of 3 cells. You can see how it would be like there are 3 box rows in every box. You're looking for a box row with all 3 digits known. So this has 2 digits known, this has 1 digit known. We don't have any with 3 known. So we're going to skip that step because we didn't find any. Last thing, you're looking for a row or a box that has 4 or fewer open cells. So like this row has 6 open cells. That's not 4 or fewer. And there aren't any here either. So that's it. Now we move on to the next band. We just repeat what we did. So I'm going to start with this box. I'm going to look for a 1 in both of these boxes. I don't find it. So now I just have to compare these 2 against each other. 3, 5, and 8. I'm looking for 3, 5, 8 over here. I don't see it. So there's actually no repeats here. Next thing we're going to look for is a filled box row. We don't have any of those. And then we're going to look for a row or a box that's down to 4 or fewer. I don't see any of those. All right, so there was actually nothing to do in this band, which is surprising given the number of givens, but that's okay. We are going to move on to the next band. So I'm going to start over here, the 1 and the 5. There's no 1 in any of these, but there is a 5. So we have a duplicate 5, and that lets us corner mark a 5 into one of these 2 cells. Now I just compare these 2 against each other. There is a 2. Those 2's look over into there, so there's a 2 in one of these 2. The 3 does not have a buddy here. The 7 does not. The 9 does. We have these 2 9s looking in. There's a 9 in one of these 2. Now, when this happens, I want that to trigger something for you. That is, we have found a hidden pair. Now, the pattern you're looking for is when you have 2 digits that overlap in exactly 2 digits corner marked in exactly 2 cells, and it's the same 2 cells for those 2 digits and no other cells. Right? If I had another 2 corner marks somewhere, like where this 5 was, if there was a 2 possibility here, we don't have that. But here we've got 2 cells with 2 digits corner marked identically in them and nowhere else. Those digits don't appear anywhere else. So what is the logic here? Well, the logic is that within this box, the 2 must appear either here or here. In our final solution, the 2 will be in one of these 2 cells. That's what the corner marks are telling us. The 9 is the exact same story. In this box, the 9 will end up in this cell or this cell. Well, we can't have the 2 and 9 appear in the same cell as each other. And so there's only 2 cells that can accommodate them. So those 2 cells must accommodate them. One of these will be 2. One of these will be 9. We don't know which is which, but we know that nothing else goes in there. If I tried to put, for example, an 8 here, even though there's no violation in the row, the column, or the box, there's no immediate violation, we know that we've broken the puzzle because we cannot fit both the 2 and the 9 in the box, and the 9 needs both digits. One of them can go here, but the other one has nowhere to go. The 8 took one of the spots. So we're not allowed to do that. So this is very powerful. A hidden pair, any technique that I say is hidden, first of all, it means that we focused on either a row, column, or box to find it. And then secondly, it means that it restricts what certain cells can be. The cells that we found the hidden pair in, those 2 cells have now been restricted. They can't be every digit that Sudoku, basic Sudoku would make us think they can be. And so we're going to use center marks to denote that. What center marks mean, I'm going to get rid of the corner marks. because we don't need them anymore in this case. What the center marks mean is look at this one cell. Look at the cell. This is the list of candidates that cell can be. In the final solution, I know for a fact, because I have logically proved, that this cell will be a 2 or will be a 9. I don't know which, but it will be one of those two. And that is the comprehensive list. It won't be any other digit other than 2, 9. Same with this cell. This cell won't be any other digit other than 2, 9. And we proved that via the box. And so this is very, very powerful because now what we have with this 2, 9 pair, what we've done is we've removed the possibilities that otherwise could have gone in here. So one thing we can do is we want to sort of follow up on that hidden pair and think about the consequences. And the consequence is that we have removed they already couldn't be 1 or 3 or 4 or 5, but we've removed the 6, the 8, and then the 6 and the 8 were removed from here. So that affects 6 and 8. So we want to see, like, are 6 and 8 additionally restricted anywhere here? And if you have a keen eye, you will see that, because we're looking for 6s or 8s around here, you'll see that we have a 6 and an 8 up here that tell us this cell also can't be 6 or 8. So where do the 6 and 8 go in this row? Well, they go here. Now, I'm not necessarily expecting you to see that in the first pass, but I think it's a nice demonstration of, if you do think about the consequences of what you've just done, sometimes you can find really cool things. So this cell can't be 6 or 8, but we need to place both a 6 and 8 in the row. And so we found another hidden pair. This is a 6, 8 hidden pair. And this 6 actually tells us the order. So if we actually think about the 6 on its own, where does 6 go in this row now? This 6 says not here. This 6 says not here. And so 6 ends up here. And we found that purely by just thinking about what were the digits that we removed from these two cells. And so the 6 gets placed here for the row. The row needs a 6. This is the only cell that can be, because these cannot be, because they have to be 2, 9. And now we can repeat that with the 8. In this row, we need an 8. This 8 says not here. So only one cell left that can be 8. And now if you think about it, there's only one digit not accounted for in this row. We know the 2, 9 end up over here somehow. So those are accounted for. We know this can't be 2, 9. They'd also seize a 2, 9. And so that means that this is the 1. The row needs a 1, and so that's where the 1 goes. All right, we just got a bunch of new digits. So we need to rescan what we've already done here. So, for example, does the 6 or the 8 have a buddy? Does the 1 have a buddy? The 1 does have a buddy. And so we can fill this 1 here. Okay, so I don't think there's any new buddies beyond that. However, the next thing we look for after looking for buddies is we look for filled box rows. And we have a bunch of those. So let's start with this one. What are we looking for? Well, we're looking at the 2 rows that box row isn't in the band, and we're looking at the box that it isn't. So it's going to be 12 cells that you're looking at. You can see how this works, right? And what we're looking for is we're looking for any information that isn't already in this box. We're looking for digits not in this box. So the 1 already in the box, the 2 already in the box, 9 already in the box. The 5 is not. We already got these 5s though, because we had this buddy here. But if we hadn't gotten these 5s, this is when we could have. But that's all we get from that. This is these are filled, but also I'm noticing that this box is just down to 2 digits. So you'll notice that what this does is it lets us corner mark extra stuff within the box, but this box doesn't need any more corner marks. It's down to a pair. By this time, I would have already filled it if I wasn't using the systematic method, but this is down to 3 and 7. I'm just going to center mark that. And then these count as kind of buddies for the 3 and the 7 over here, because we know that one of these 2 will end up 3 and one of these will end up 7. And so this 3 can buddy up with whichever one of these ends up 3. It's going to buddy up with that. Taking 3 out of here, we have these 2 3s looking down. We can place the 3 in this box. Same with the 7. The 7 buddies up here. Take 7 out of these, and we can corner mark 7s up here. So we did that instead of dealing with the box rows. But now, if we hadn't, we would have immediately done it by looking for rows or boxes down to 4 or fewer digits. This was down to 2. We already marked it up. That's all we need to do. We also have this box and this row. Let's just focus on the box first, just because I'm just going to, basically every cell is going to get focused on, because The rows, the boxes, everything are down to 4 or fewer. But let's just think about it first. So here we have 1, 2, 3. The box needs a 4, 5, 6, 8. Now we know this cell can't be 6 or 8. So this cell's down to 4 or 5 only. We're just going to center mark it. We can center mark, I would recommend only center marking cells that are down to 3 or fewer candidates. But if we do find one with 3 or fewer, let's just go ahead and mark it. So we were down to 4, 5, 6, 8. None of these can be 5. And we have this 6 and 4. So if I fill 4, 6, 8, you can see this can't be 4 and this can't be 6. This can't be 4 at all down here. We can actually corner mark 4 on one of these two if we want. And we know this is down to 5, 6, 8. So this was all worth marking. Now we have this box as well. You'll say, well, what about the open 2, 9? Well, we know the 2 and the 9 go in one of these two. And so the box for these cells doesn't really care which one ends up 2, which one ends up 9. To the rest of the box, the result is the same, that the 2 and 9 are basically known. So the remaining digits are 4, 6, 7, 8. I'm just going to fill that. Actually, neither of these see 4, 6, 7, 8. So I'm not going to mark those. This sees an 8, so this is only 4, 6, 7. I think this can be also any of 4, 6, 7, 8. So I don't think those are worth marking. Okay, so this band we got quite a bit out of. You can see we got way more than these other two bands. Now what I'm going to do is I'm going to move on and do the stacks. So we're going to do the exact same thing with stacks as we did with bands. So I'm going to start here with this 6, 8. We do see that the 6 has a buddy. If we hadn't already, but we could have already had these marked, but now we definitely do. The 8 does not have a buddy. Okay, now we just compare these two against each other. The 2s look up, putting a 2 up here. And then we have the 4. The 4 doesn't have a buddy down here, so we don't have a buddy up there. We've got the 6, no 6, 9. We have the 2 9s looking up. 9's in one of these 3. Okay. Any filled box columns? No, I don't see any. Any columns or boxes down to 4 or fewer? This column is down to 5. This column is down to 4. So we can think about this column. We have 1, 2. We need 3, 4, 5, and 7. Now we know neither of these are 4, so we can fill 3, 5, 7. This one's not a 3. And what we're looking for when we fill these, as soon as you fill them, you're looking for whether that matches up with anything we've also marked up. Like, is there another 5, 7 somewhere? Is there maybe a full set, another thing that can make us a 3, 5, 7 triple, right? We're looking for that as we go. And if I find one, I'll explain how those work. Now, 3, 4, 5, 7 here, this can be any of those, so I'm not interested in marking that. There's no box down to 4 or fewer, so I think that's it for that stack. Let's move on to this stack. This 1 does have a buddy. They look up, putting a 1 in one of these two. Oops, corner mark. The 4, 6, and 8. We do have the 4. These 4s all look in. We have the 6. You know the drill by now, hopefully. The 6 is in one of these two. And the 8. We have these 8s looking down. And this 8 looks in. That places the 8 in this box. It's the only place for 8 in this box, so it's a hidden single 8. Now, this 8, is when we placed it, we need to follow up on what we've already done. So first thing, we look for buddies in the band. And so we have an 8 down here now in one of these two. Next thing we look to see, did we fill up a box row? We did not. Did we cause a row or box to be down to 4 or fewer digits? We did not. So that's all we've really looked for so far. So now we've followed up on this 8 properly. We have dealt with all of the buddies. Now we look for any filled box columns. We have one here. So we just want to double check these. I think we already took care of them, but there's already one in the box. Really, it would just tell us about this 3, 7, which it can't because it's a vertical thing. So really, we're not going to find anything. The 4 and the 8, the 8 and the 6, they don't do anything. Only 3s and 7s could do something. So we're not worried about that. Now, any columns or boxes down to 4 or fewer? This one's down to 4, so let's think about it. We need a 2, 3, 5, and 7. I think all of these can be all of 2, 3, 5, 7. I'm not seeing anything. So I'm not going to mark that up. There's nothing else really here to look at. So I'm going to move on to the next stack. This 3 does have, there's 3 3s, so we can't do anything with that. We also have the 5 and the 8, so the 5s do look up. Putting a 5 somewhere up here. Any filled box columns? No. Any columns or boxes down to 4 or fewer? No. Okay, so this is what I was saying at the start. We definitely did not finish the puzzle in our first pass, but we did get some nice, easy information that wasn't that hard to find by focusing on those things first. Okay, so the next thing I want you to do is I want you to go box by box. And what we're going to be looking for is we're still going to be focusing on the givens. And we're going to be looking for what I call crossings. So what a crossing is we have two givens that share a row or a column are the ones you really want to focus on. But really you can focus on any pairs of givens. Because there's always going to be at least one row and one column they aren't in, because 2 digits can't occupy 3 rows or 3 columns. So anyway, these occupy the same column as each other. So what we want to do is we want to look at the row they aren't in. We want to see if there's any digits there that kind of peek through that the box doesn't already have. In this case, we do not. So we can ignore that here, the 6 and the 8. So I can shortcut a little up here. Because I know, and we know at least horizontally with this 6, 8, right? These are the digits I would be caring about to find crossings. And the 3 is the only interesting one. And there's no 3s placed down here. So I can't do anything with that. This 4, 8, again, the 3 is the only digit in this entire band that's not already in this box. And there's no 3s vertically, so we can just skip that. There's only one given in this box, so we can skip that. All right, now we have this 2, 4, 6, 9. Let's look at this 2, 6, for example. So the 1 and the 5 would be candidates. So we actually find something. So let's go over this a little slower. I'm focusing on these green cells, the 2 and the 6. They share a column. It's two givens that share a column. Because they share a column, there is exactly one row that they aren't in. That's this row. We don't care about this digits. We don't care about the stuff in the same box. So it's these 6 cells. I'm going to make those purple. We're focusing on these purple cells here. We don't care about any cell, anything there that won't give us any new information about the box. We just care about the 1 and the 5 here, because 1 and 5 still need to be placed in this box. Now what we do is we look at the 2 columns they aren't in. That would be these 12 cells here. And what we're doing is we're looking for duplicate digits, a 1 or a 5. I'm looking for a 1 or a 5 in these 12 cells, and I actually find the 1 here. We don't find a 5, so I'm going to uncolor all of these. So what are these going to do to the box? Well, on their own, they remove 1 from 5 of the cells. These cells that I put in gray cannot be 1 because this one looks in and this one looks in. And not by coincidence, by design, the 2 green cells are not touched by those 1s because we only looked in rows and columns they weren't in. Right? Since we looked at rows and columns they weren't in, they're going to go right past them. Right? So there's going to be 5 cells that these remove the 1 from, and there's going to be 2 cells that already that we focused on that were filled with givens that also can't be 1. And so there's only 2 cells left in the box. There's always going to be 2 cells left that's not touched by the crossing that you found and the original digits they cross in front of. And so that's always corner markable. In this case, the 4 is happening to occupy one of them. And so we actually know where the 1 goes in this box. The 1 in this box must go exactly here. It is a hidden single 1 in the box. It's just a little bit harder to find because essentially our buddies one came from a row and 1 came from a column, and that's much harder to scan for. So that's why we wait and we scan for that when we have to. Now we place this 1, we want to follow up on it. We need to follow up on both the band and the stack scanning. I'm going to start with the band. So the band, these 2 1s look in, this 1 looks up. That does place this 1. Remember, we're going to have to follow up on this stack as well. But let's actually just mark that green, right? There's no reason you can't use aids to help you remember what you want to follow up on. So we'll follow up on that 1 after I'm done dealing with this 1. This one also vertically, I'm just going to put 1s up here because we have a buddy there as well. Now, did I fill up a box row or a box column? I did not. Did I cause any row, column, or box to be 4 or fewer digits? I did not. So we have finished following up. Oh, actually, no, the rest of this box. This box is now down to 4. So 3, 5, 7, 8 is what's left. This can't be 3, so this is down to 5, 7, 8. Oh, it can't be 5 either. There's a 5 in the row. Oh, that's handy. So we'll deal with that in a second. This can't be 5 or 7, so this is 3, 8. Now we notice that because this 5 looked in here, we actually end up with a 5 in only one of these 2 cells. And you can see that from our center marking. So we want to corner mark those 5s there. Now those 5s are going to do what's called pointing. Pointing is very powerful. So this is the first time we've encountered it in this puzzle, which is a little surprising. But pointing is when we've corner marked a box, right? And these 5s, they share a column, right? So in this box, the 5 will end up here, or it'll end up here. Any shared consequence between any consequence that doesn't care which one of these 5s is true will be true no matter what. That consequence will happen when we place the 5 here or when we place the 5 here. So for example, look, if I place the 5 here, this cell can't be 5. The only other option is I place the 5 here, this cell still can't be 5, right? This column can't have 2 5s in it, and we know it's in one of these two because the box told us so. So when the box tells us that a digit is restricted to a row or column, that column has to respect it, and that's called pointing. Because if we drew a line between these 5s, we kind of draw an arrow across the rest of the column and say, well, the rest of the column can't be 5. And so if this is not a 5, we've now removed everything but 4 as a candidate to this cell. So this cell is now a naked single 4 because it can't be any other digit, can't be 5 anymore. And so we place a 4 there. And that we also removed a 5 corner mark. There's now only one place for 5 in this box, so we can place the 5. That removed a 6 corner mark, we can place the 6. And for many, many reasons, this is an 8. So it's the last digit for the box. We could have done that in a different order. We could have done it as naked singles. But anyway, this 8, we can do this in any order we want, but this ends up at 7 and this ends up in 8. That ends up at 3, that ends up at 5, right? One way to do it is this 8 corner mark is no longer viable. So this is the only place in the box for 8, so we can place it. And now there is only one place in this box for 3. Now there's only one place in this box for 5. Now there's only one place in this box for 7. We can also do it in the complete opposite order by saying this 8 makes this a naked single 7. That 7 makes this a naked single 5, which makes this a naked single 3, which makes this a naked single 8. It's not a coincidence that hiddens and nakeds are kind of polar opposites of each other. You find them in opposite cells. Anyway, we just filled this entire box and this entire box. This 4, we might as well clean up this 4 over here. Oh, we also had this 3-7 pair here, and I completely ignored that when I filled this cell. That was a mistake. Luckily, when you make mistakes using this method, usually the mistake is just extra markings, not too few markings. So it couldn't have caused us to fail the puzzle, but it could have caused us to take much longer on the puzzle. So this 3-7 pair tells us that 7's in one of these, which means this can't also be 7. And so because it can't be 7, it is a naked single 6. That means this row just has one digit unaccounted for. It is the 8, so we can just place the 8 for the row. We might as well finish the rest of this row as well. So we've got the 1, 2, 3. We need a 4. We have the 5, 6. We need a 7. So this is a 4-7 pair. Now placing this 6 did get rid of this 6. Placing this 8 got rid of this 8. So now this is the only place for 6. This is the only place for 8. And now this is the only place for 5 in the whole box. We're getting so much right now that instead of following up, my recommendation is scan the puzzle for rows, columns, boxes down to 4 or fewer and focus on the one with the fewest first. So this column has just one digit left, so we can just immediately place it. If there's one digit left, you place it. So we place the 7. I'm seeing that these are down to triples. That could be helpful. This is down to 4. I'm not seeing anything more restricted. There might be, but I'm just going to focus on these first. So I already know that this is 2, 9 from my corner marks, but then there's going to be one more digit. It's the 3, so this is 2, 3, 9. This one's not 3. And then this is going to be the digits that we didn't get. So 1, we have the 2, 3. We need 4 and 5. We have the 6, 7, 8, 9, right? So that's not 5. That's not 4. Okay, so we didn't get anything more out of that, but that does tell us a lot more about this box for when things peek in. We also have this column, which is down to 2, 4, 7, 9. This can't be the 7 or the 9, so this is only 2, 4. And this can't be 4, so this is 2, 7, 9. Okay. This row is down to 4, so we'll think about that as well. We have 1, 2, 3. We need 4, 6, 7, 9. Well, this one's not 4, so it's 6, 7, 9. This one's not 6, so it's 4, 7, 9. These can be any of 4, 6, 7, 9, which is... Oh, no, this one can't be 6. So this is 4, 7, 9. But this can be any of them. Okay. How about the rest of this row? Oh, yeah, I was going to follow up on this 1. We'll do that in a second. We need... I marked it and everything. We need a 2, 5, 7, 9. So this can't be 2 or 5. So this is down to 7, 9. This can't be a 9. So this is 2, 5, 7. This can be any of 2, 5, 7, 9. All right, let's follow up on this 1. We do have a buddy. So there's a 1 up here somewhere. I think that's really all we get out of it. So I'll just remove that now. I could have just marked that when I first placed it. I thought there might be more though. Okay, we may have to do some scanning follow-ups because I guess we do have this row. If we run out of rows or boxes or columns down to 4 or fewer, that means we just need to go back and actually follow up on our scans properly instead of sort of taking this shortcut. So this row is down to 2, 3, 4, 6. This one's not 2 or 4, so this is 3, 6. This one's not 3 or 6, so it's 2, 4. So this is a naked 2, 4 pair, or alternatively, this is a hidden 3, 6 pair. You can think about this either way. They're two sides of the same coin, right? One way you can think of it as neither of these cells can be 3 or 6. We have these 3 6s telling us that. But this row still needs 3 and 6, so we have a hidden 3, 6 pair over here. That would make this 3, 6. This can't be the 6. We place the 3, we place the 6. We get the same exact result if we just look at this 2, 4 pair as a naked 2, 4 pair, which is actually useful for the box as well. So let's take this naked 2, 4 pair. This cell is going to be 2 or 4. This cell is going to be 2 or 4. And they cannot both be 2 and they cannot both be 4. That breaks Sudoku rules. So one of them must end up 2 and one of them must end up 4 so that they can both have a value. As soon as one of them is a 2, the other one must be 4. And one of these will be a 2, right? One of these will be 2, one of these will be 4. No matter how you slice it, that's just what's going to have to happen. And that means anything that sees those cells, it sees both of them, doesn't care which one ends up 2, which one ends up 4, they still can't be 2 or 4, right? There is no world in which this can be a 4. There's no world in which this can be a 2, because the 2 and 4 are going to end up down here for the box. So this is not 2, this is not 4, this is not 4, that places 4 in the box. And that leaves 3, 6 here, and this can't be the 6. So that's a 3, that's a 6. Notice we got the same result. I knew we would. But we get an extra result here of getting the 7, 9. So there's a lot we can do here. Let's take some really low-hanging fruit. This 3 makes this a 7 and a 3. Naked singles. Okay, we have this 7, 9 pair here. This isn't 7. That means this is 2 or 5 to finish off the box. It also finishes the row. We have this 7, 9 pair. This box has 1 digit unaccounted for because we have a 2, 4 pair and a 7, 9 pair. This is whatever digit's not accounted for, which is the 6, it looks like. We place the 6 there. Very nice. It looks like that's what we needed. This puzzle's not going to hang on much longer. We need a 2, 5, and 9 to finish off this column. And one thing I'm noticing is 9 is in one of these two, so that could be helpful. This column, we need 2, 4, 7, 9. This one's not 7, it's 2, 4, 9. Oops, I meant to be in center mark 1, 2, 4, 9. Oh yeah, we have this 7, 9 pair here in the column. So this is the pair that remains. It is the 1, 3 pair. This 3 tells us that this is the 1, and this is the 3. That means that this 1 tells us this is 5. Okay, we're left with a 1, 4 pair. 3 now can only go here in the box. Clean up this 1, clean up this 5. Okay, the rest of this box is 2, 5, 7, 9. The 7 can only go here. We had this 7 here. This isn't 5, so this is 2, 9. So 5, oh, this isn't 9 either. So this is the 2, this is the 9, this is the 5. We get the 2 and the 9 resolved. That's not a 2. At this point, it'll just resolve no matter where you look. 5 and 9 get resolved. This row needs something. It needs a 7, so we place that. Gives us this 7, 9, and this 9, 7. Gives us this 4, 7. Gives us the 2, 4, which gives us the 2, 9. This puzzle's collapsing. This is 4 or 9, but can't be 9. That's 4, that's 9. That's 1, that's 4. We need a 1 and a 2. They go like that, and we're done. All right, well, hopefully that was helpful and instructive for you. Hopefully you enjoyed the solve. If you did, then why not leave a like, subscribe, and a kind comment below.